In this video, I'm going to talk about these three things. First, upload a video file to Google Cloud Storage by Firebase. 2. Watch a video file from the file in the Google Cloud Storage. And 3. Run Firebase emulator for development. So let's get started. At first, I'm going to think what I have to care to upload a video of anime. Of course, it's an anime, so the format of the anime is the video file mostly. But the video file itself is big, so there are a few things I have to consider. First, you cannot upload a file simultaneously with other metadata like the title of an anime or whether it's published or not. And I want allow other users to watch the video file only after user publishes it. So we have to manage permissions for the video file. And I'm going to use security rules of Firebase to manage the permissions for that file. And also, I want to monitor the progress of whether uploading a file is completed or not and show the progress on the screen. And I'm going to use the upload by the resumable function provided by Firebase. Actually, these are the biggest reasons why I decided to use Firebase. And of course, the file is provided by a user, and there are many options for video files, but some of the video files may not be able to play on the web service. So I want to limit only a few types of video files, such as MP4 file. So this is the UX for uploading a video file. Like I talked, a user at first uploads a video file, and then browser uploads the files asynchronously and shows the progress to a user, and it will keep doing until uploading the file completes. And at the same time, user can enter the metadata of the video file, like the title of an anime. And once uploading a video file and enter the metadata of the video file completes, then a user can submit it. Once you submit it, a browser updates the metadata of the video file on cloud storage, so it publishes it to other users, and then it redirects to the page, to the video page to the user. Then about the security rules I mentioned, basically the rules are simple. First, a user can upload the file and watch the file for their videos, of course, but other users can watch a video only if it's published. And in order to implement these rules, we will implement these ways. First, manage if a video is published or not by its metadata. So I'm going to define visibility metadata and set public if it's published, and store videos under videos/user ID directory, so the user can read and write their videos. But other users cannot read the videos until the metadata visibility is public. And in order to deploy these rules, just define a storage rules file created by Firebase init CLI and then deploy it using the CLI as well. So this is the security rules I mentioned. Basically, it's just like I said. I first define the function and check whether the video file is public or the file is owned by the user, and it's used for the read permission. And for write permissions, it's only allowed by an owner of the video file. That's it. And next, I'll talk about the implementation of the real TypeScript code. To upload a file, I just used input HTML element and write an onChange handler. And yeah, just get the file object and to get the content type from the file object, and use the ref function provided by Firebase, and I use upload by its resumable function as I explained, and then monitor the on progress on error and on complete event handlers. And once uploading is completed, then a user can submit it. And for submit functions, I just updated the metadata using update metadata function provided by Firebase. And once it's completed, just redirect the page to the video page.
For implementation, we also need to think about how to handle errors. Of course, to access Google Cloud Storage, errors could happen, and the list of errors to access Google Cloud Storage are described in the Firebase official document. So from them, I classify the errors into something that can be handled differently while uploading a video. And errors can be identified by error codes, so I use error codes to identify which error happened. So I just decided to handle differently for two types of errors. First is unauthenticated error. In this case, user needs to sign in at first, so I decided to redirect the user to a sign-in page. And for cancelled error, this could happen in a normal flow, like a user tries to upload a file while uploading a different file. In this case, it's completely normal, and I think error message should not be shown in this case, so I decided not to show anything for this case. But for other errors, users can't fix the error, so I just decided to show an error message. Unfortunately, this can happen temporarily, time by time, due to many reasons like release of new change. So this is the code to handle errors. Basically, this is something I already explained. And I just decided to throw an error when the unexpected error happens. And I haven't implemented a global error handling, but it should be handled so that errors doesn't show to a real user. But I'm going to decide how to do it later, not in this video.
Then next, I'm gonna think how to watch a video of anime. And at first, I need to figure out which video a user requests. And I decide to include a video ID in the URL, not a query string. But I don't have a strong opinion. I think that I included the parameter in the URL is more natural in this case. But not only for that, we also need to figure out who uploaded that video file, because the user ID is included in the URL of cloud storage. And that user ID will be stored in the server side. And I decided not to handle it in this video, but gonna handle it in the next video. And also I decided to check the content type of a video file where it's played, so that it ensures we only play our supported videos. Next, let's think about error handlings. It's not very different from what I did for uploading a video file, but the types of errors could be different from the uploading a file. So for watching a video file, I just needed to think two errors. One is object not found errors from cloud storage, and for this case, this case could happen when user tries to access the video where there is no video. So in this case, we just show this video doesn't exist to a user. And other case is a user cannot watch the video due to the lack of permissions to the cloud storage on the security rules. So even though I don't implement anything to unpublish the video file, it could happen in the future. So I was thinking about this case as well. and handle this case and shows the error message that the video is private when this happens. And for other cases, I don't think handle it should be handled separately or differently from others. So just show error messages. So these are the errors I faced while I was working on. Basically, when I was working on uploading a video file. One is when I tried to upload a video file, I got not found the error, and I just forgot to enable storage on Firebase. So after I enabled it, it was resolved. Another error was the tough one. I got the errors for cross-origin request blocked, blah blah blah, for some reason, and I was able to solve it by using the different browser. I originally used Firefox in order to separate the main browser and the development browser, but I decided I couldn't solve this issue, and I started using Google Chrome, and it resolved. Switching the browser resolved the issue for some reasons. Of course, I tried to set the CLRS configurations on the bucket using the CLR, but it didn't help at all to resolve this. So I'm not really sure the root cause. So this is the code to watch a video file. Yeah, it's a part of the video, part of the code. So basically, we have to get the reference for the video file using the function called the ref provided by the Firebase SDK, and then use get the metadata to fetch the metadata of the video file and check the content type, and also use get download URL function to get the actual URL of the video file, and then use this content type, this metadata and the URL, render video HTML element. Yep, just use the HTML video element and the source element. Next, I set up Firebase emulator because I use Firebase Auth and Firebase Cloud Storage for local development, but it's definitely better to use the emulator for local environment so that it doesn't charge anything for the usages hours, even if I upload as many video files as I want. In order to install an emulator, it's actually a little bit straightforward, except that I needed to downgrade the Firebase emulator version from 11 to 10.9 because of this bug which was reported on GitHub. And I used the standalone binary and how to downgrade the version of a standalone binary was described in the install script, so I just followed that way. So in order to install Firebase CLI, I needed to install JDK version 18 at first. Then after that, I just need to initialize emulators. And one thing we need to keep in mind is that if the project ID has the demo prefix, then Firebase emulator identifies that project as a demo project. And it is supposed to prevent accessing some services that are not emulated. However, I couldn't figure out how to do that. Even if I try to use these features, basically set up the emulators, and the code tries to access services not emulated, and then it didn't fail. Yeah, it succeeded unexpectedly. Then in order to, after running an emulator, you can access the Firebase emulator services on local host 4000 port number. Also, if we run the web service with the emulator like environment variables, we can run the application like this. But I need to update the application to use the different environmental variables in without local. And the drawback of this approach is that every time emulator stops, a web service, every time a web service needs to restart, emulator also restarts, and some of the data will be lost. So I may need to like think or look into the solution, but I haven't checked it yet. Okay, so this is the demo for after I implemented today's videos. So this is the emulators, and you can see that there's a text on the bottom of the screen, and also you can see that the screen for Google Sign In is different from the real Google Sign In. You know, with a Firebase emulator, we can input the arbitrary email or username, and then after that I choose the file for whatever the file for the video file. This is like emulates to upload the video file on the Google's Firebase emulator, and once it's uploaded, it redirects to the video detail page. And then this is the Firebase emulator screen, and it is uploaded on the cloud storage. So in next videos, I'm gonna set up a server-side code and store data into the database, and probably I'm gonna use the MySQL. And then I'm gonna implement to integrate with that server side, like authentication or uploading a video or watch the video. Yeah, that's it in this video. Thank you for watching. Bye.